Hello, my name is Dave McCarthy. This video is for medical physiology at the University of England. Today we're talking about anatomy and enzymology of fat absorption. This all begins with bile. This is a non-enzymatic solution created from the hepatocytes of the liver. Main contents of bile is going to be bile salts, biopigments, and cholesterol. This is usually secreted into the gallbladder via the hepatic ducts, okay, then into the cystic duct. It sits there as a reservoir and then is concentrated until when needed. So when you start eating meals that are high in fats, the gallbladder will send the bile then down the common bile duct into the duodenum, okay, and there it will aid in fat digestion. So mainly the bile salts help facilitate enzymatic fat digestion and are made up of bioacids in conjunction with amino acids. Okay, so we can see how this starts here in the liver. The bile acids become bile salts, then in the gallbladder, then get sent to the duodenum. So there, after they go through the duodenum, they're reabsorbed from the ileum and are reused, but it's not uncommon for them to reach the colon, where they're broken down into bioacids by colonic bacteria, then to return to the liver via the hepatic portovein. Usually during a meal, these are recycled about 2 to even 5 times in order to really break down all the fats that we take in with our meal. Most of the digestion occurs in the small intestine within a large process of the breakdown within the duodenum. So we have intestinal, hepatic, and pancreatic enzymes being secreted, all working together. Even with the pancreas, it's secreting a lipase, colipase, and phospholipase to aid in the digestion. So the big thing with biosalts are they are amphipathic, which is they're hydrophobic and hydrophilic. Okay, so they're able to move real versatile in order to get to these fat droplets to help break them down. A lot of these lipids are, the primary source of our lipids are triglycerides, so usually they're hydrophobic. And when the chyme comes from the stomach in these large fat droplets, they just need to be broken down. So the bile salts are first there to break down the large, and then once they're broken down, then the lipases go to work in conjunction with them in order to further break down the fat droplets. Then, once we get them down even more, the next step involves when we have the residual mono and disaccharides. They're surrounded by meshal, which is a hydrophobic interior and a hydrophilic exterior. And basically this helps them transport these droplets more easily in aqueous solution. The meshal react very easily with the walls of the intestines, and by way of simple diffusion are able to get these droplets, the mono and disaccharides in, where they're formed into triglycerides and then packed with the Golgi in order to get into the lymphatic system. And once they're in there, then we make sure they're transported by the chylomicron, and so they're not large enough to enter the bloodstream, but it can stay in the lymphatic system, which will further break them down later. And so once they do this by exocytosis, once they reach the heart by way of the venous system, entering at the right atrium, as we can see right here. So this is basically how our fat is mainly broken down with once it enters our body, the biosalts really breaking down those big droplets, and then in conjunction with the lipase and the meshal in order to further break them down and then transport them where they actually need to go. Thank you very much.